Hello, everyone. Welcome to another interesting topic into this our AWS series. Today, I'm going to talk about something different, as I promised during my last session, that I'm helping someone with doc porting one of their application to the Docker and how they can really make use of a Docker AWS. So, in the last session, we talked about the Elastic Beanstalk. Today, we're going to talk about Docker and how can you run Docker on Amazon, and we'll run our Docker instance on top of our EC2 instance, and then we'll run our Java application inside our Docker container. And then later on into this series, I will show you how we can integrate that whole this thing that we're going to do in this lab with our Elastic Beanstalk to make it more automated deployment, that kind of thing. So this is not like a full-fledged Docker video or Docker introduction, but I'll give you a basic introduction about Docker. Maybe into some other video series, I can explain you more about Docker and how to really work with Docker. So this is a very basic introduction about Docker. So Docker is an open platform for developing, shipping, and running your applications. Docker is designed to deliver your application faster. That's the whole idea. Docker helps you ship code faster, test faster, deploy faster, and shorten the cycle between writing code and running the code. So that's the whole idea. Docker does this by combining a lightweight container virtualization platform with the workflows and tools, which are built into the Docker platform. Docker provides a way to run almost any application securely isolated in a container. So pay attention to the new term that we are saying, container here. This isolation and security allow you to run many containers simultaneously on your host. That is the whole idea. You can run multiple containers on a single host. Being the lightweight nature of these containers, you can get more out of your hardware. So that's the whole idea. Instead of running one application on one EC2 instance or one of your VM, you can run multiple Docker container on top of your one EC2 instance. So getting good more out from your underlying hardware infrastructure. And this all happens because of the Docker's lightweight nature. So as I mentioned last time, pay attention to the container terminology. So a Docker container is nothing, but it's similar to a directory, basically. This container, which we're calling is a directory, this container holds everything that is needed for an application to run. Each container is created from a Docker image. So when you create a new container, you are creating them from the Docker image, which is just a read-only template. For example, an image could contain an example. An image could be contain a base or minimal OS, let's say in Ubuntu, running with Apache, as well as your application already pre-installed into that image. And you can just pretty much use that image and start deploying multiple container. That way you don't have to deploy any base OS. On top of that, you don't have to install any Apache, and then your application, everything is bundled together within one image or within one container. So you can have multiple of those containers. So Docker provides a very simple way to build new images. You can go ahead and create your own images also, or you can take an existing image and you can update that image with your own add-ons. So that's what something we're going to do in this lab. They will take an existing image. We will go ahead and add our own stuff into that image, and we'll we'll make a new image from the existing image plus our changes, basically. You can download Docker images that have someone has already created and use in your environment. You can create, start, stop, move, and delete a Docker container pretty much. Docker containers are the run component of your Docker environment, basically. A container consists of an operating system, some of your user-edit files, and some metadata. Each container is built from an image. So as we discussed earlier, an image is nothing but your read-only template. That image basically tells Docker what the container holds, what process to run when the container is launched. Like as we discussed earlier, okay, we have a container with a base OS of Ubuntu running within Apache in your application. What process to run when the container is launched and other configuration data. Docker image, as we discussed earlier, is a read-only. When Docker runs a container from an image, it adds a read-write layer on top of the base image. What we're calling the base image, the image that we used to spin up a Docker container. So the read-write file system that we are creating on top of that image is known as basically union file system, or you can go and read more about the union file system in which your application can run. Basically, your application can run, and that's how you get a writable file system. Uh, Once you create your Docker image, your own, that again becomes a read-only template. So hopefully, you got a basic idea that Docker is just an open platform for developing your application. It makes everything pretty quick. Another good thing that it's a very lightweight, so you can run multiple containers, and because there is a good isolation, so which allows you to basically run multiple container without any worry that will be one container can harm the other, or vice versa, and some of the other details. So in this lab, like as I said, I have already went ahead and created an EC2 instance. We'll use this EC2 instance as our main host, where we're going to install Docker and Docker daemon, Docker client, and then we'll go ahead and on top of that, we'll go ahead and launch some of our Docker containers. And later on, we will bundle one of a sample application within a container. And then later on in the part 2 of this series, I will show you that how we can integrate this whole thing with your Elastic Beanstalk. So I put together some slides, just basically walks you through the certain commands, what are we doing, but I'm going to show you everything in a live demo. So let's go back and let me start sharing my Amazon EC2 console, and let's see how far we on the creation of my EC2 instance. I went and already provisioned an EC2 instance where we're going to host our, okay, let's look at the one running host here. Okay, it's almost done. Very good. So let's go ahead and do an SSH to this host. Give me a second, guys. Let me go ahead and SSH to the host, and then I'll share my other screen with you. Okay, hopefully you guys are able to see my secure terminal here. The first thing that we'll do here, let's go ahead and like make ourselves a root so we don't have to type commands again using sudo over and over again, but it's good practice. So now let's go ahead and install our Docker here, as well as the Git. We'll be using the Git later into the part 2 of our this series, but I'll go ahead and provision Docker and Git on this host. So we'll take a few minutes, and we have our Docker installed. Now let's go ahead and start the Docker service if it's not already up and running. So you can see it started the Docker. I will add this into the startup also, making sure once we reboot, it comes in active. So let's go ahead and verify a few things here pretty quickly. Let's look at the Docker version that we are running here. So we are running a client version of 191, a server version of 191. The version of the Go that we are using is 142, and some of the other details that we can see. Look, if are there any existing images on this one? No, as I mentioned, there are no existing Docker images. And let's verify another thing, that we don't have any existing Docker container that we started earlier. So we just installed here everything, and everything looks good. Let me go ahead and launch one more instance of our terminal so I can show you a few things later into the lab than when we are working with. So give me a second, guys. Let me go ahead and copy the public IP of our EC2 instance. Okay, I'm logged on here. Just change this terminal also to sudo. Let's jump back to our first terminal here, guys. And the first thing that we're going to do in this lab, we'll go ahead and the application that we're going to deploy, it's a JBoss application. So I'm going to download an image from Docker registry, an official image from Docker registry, our JBoss image, which is supplied by Red Hat in this case. So it's very easy. You can go to the official Docker registry, which is hub.docker.com, to look for different images which are out there, and depending on your need, you can download, or you can build even your own, and later on can make use of that one. But I'm going to use the JBoss image already out there, which will give us a working JBoss environment, and later on it will be easy for us to go ahead and just deploy our Java application. So as you saw earlier that there are no existing images on this one. So let's go ahead and get an image. So we'll use the pull command here, and JBoss wildfly. So give it a few minutes, guys. I will go ahead and start downloading this image, and this will install the Docker image in your local image registry. Once that is done, we'll go ahead and look into our local image registry. So we'll take a few minutes, and you can see it's doing right now download. So we'll be done. Once the download is done, it does an extraction. So you can see here it started to extract that image. So give it a few minutes. Once that is done, we'll have an image, and we'll use this image to run the JBoss server, just to make sure that we can run the JBoss server and everything looks good. Okay, and as you can see, it says the status downloaded newer image for this is the latest, and this column latest is nothing but tag. Uh, let's go ahead and inspect our local image registry. And as you can see that in our repository, we do have an image with the tag of latest. This is image ID, and this is the virtual size 580 MB. Now, just to make sure, we'll go ahead and test our Wildfly container, the image that we downloaded, that we can spin up some containers successfully without any problem. So let's go ahead and launch a test container quickly. So we'll use the Docker run command. The run command accepts a few parameters. So I'm specifying the -int. I basically says, okay, that we're going to run it into an interactive mode. T tells basically allocate a sudo tty terminal to this container. So, and --rm, the rm we are telling, we are saying here that, or we are telling the Docker to delete this container when we stop this container or this application. We don't have to go manually stop it or anything. The next thing, you will have to supply the image name. So in this case, it's JBoss Wildfly. Go ahead and paste that, guys, and just press enter and give it a few minutes. And just to make a note that this Wildfly image is configured to start in standalone mode. And as you can see, this JBoss Wildfly is started, and some of other information you can find out here is listening on port 8080 for any HTTP traffic. And yep, here is the management. That's what I wanted to show you. So the Wildfly image is exposing two ports here. One is 9990 for the management of these JBoss. And if you have any application deployed, you can connect to those applications on your port 8080. So we'll be making use of these ports later on during this exercise. So just remember that we are getting this Wildfly images providing two ports, or exposing two ports, 8080 and 9990. So I'll just go ahead and simply press Control C to terminate my Docker container. Give it a few minutes, and it's doing done. You can go ahead and verify. And let's do a Docker PS. So right now there are no running containers, but if you Docker PS-A, there's nothing here. Look for L. There are not no Docker instance because we specify --rm option here, guys. So just remember that, and our image is still there. So now, so what we did so far, we have just installed our Docker daemon and Docker client, and then we went ahead and pulled an image from the official Docker Hub repository, JBoss, and we tested that to make sure that we can launch some containers successfully. Now let's go ahead and launch. We'll build a custom Docker container. So we are going to build a container here, and we'll be using this Wildfly image as our base image. So let's go ahead and create. I'm going to go ahead and create a directory here, and I'm just calling it my app one. Okay, I just did a typo here. mkdir my app one. Let's go under my app one just to see. Okay, it's in the root, and we'll go ahead and create a directory here by name deploy. Let's change the permission for this directory so anybody can read and write. Now let's go ahead and we'll go ahead and create our Docker file. So we will create a Docker file, basically, and so think of it as a Docker file just as in a text file that will contain all the commands that we would normally execute, manually on the console. Instead of running on the console, we'll put together them inside a file, and then we can execute, and we can use some like a Docker build command to build an image based on the spec that we supplied in our Docker file. So let's go ahead and create a Docker file. It needs to be decaps. We'll go ahead and create a Docker file. The first line that we're going to write is a from. So the from instruction basically says, okay, hey, what base image we will be using as a starting point for our own customization. So in our case, we'll be using the image that we downloaded, which is JBoss Wildfire. So just go ahead and we'll use that name. The next line that we'll use the run command, basically run. So the run instruction basically says Docker to execute a command. So we are just saying simply, hey, go ahead and execute a command. And the command that we're going to run here, opt JBoss Wildfly, then add user.sh. So within our image, we are adding an admin user. So I'm calling that as admin, and the password is admin. Okay, once that is done, the next line that I'm typing in my Docker file, guys, just to mention one more time, this is not a course or a video on Docker. I will explain some of these things maybe later into some other videos, but I'm making use of the Docker here. So I'll explain you a few things as we proceed in this demo. So in the CMD, I have already written the command. So let me go ahead and copy paste that from my another console here. And then I'll explain you once I'm done with this, what this command is saying. And that's all we'll be writing into this file. So let me go ahead and save this file quickly, and let's do a cat on this. So I'll go ahead and re-explain. So you got the idea from the from. Basically, we are saying, okay, hey, this is the base image that we'll use as starting point for our own customization. The next command, the run command, basically we are telling Docker to execute a command. In this command, we are just creating an administrative user. The username is admin and the password is admin. The next thing that the next command here is the CMD. It's a pretty interesting command actually. The CMD instruction will start JBoss wildfly when you start the container. So here we are specifying the parameters. So we are saying, okay, hey, start in the standalone mode in the background and bind on the port, the available port 000 to be available from the outside, and your management is again 00 outside. So once that is done, this is pretty much. Now we'll go ahead and I'll run the Docker images and Docker images. I'm sorry, guys. So now we will go ahead and create a new Docker image that will have these things. So when I say these things, so we will use our existing Wildfly as our base, and on the base we are adding this as the user, and we are running this application. We are running our application so it's accessible from outside. So you can see we have done some customization to the existing base image. So now we need to create a new image based on existing image plus our own customization. So the command to do that is you will go ahead and simply write docker build. When you type the docker build, guys, remember there is a tag. You can specify a tag here. So I'm going to use a tag here. Just think of it right now just as a name. So I'm going to call it as a wildfly admin. And where are the instructions? They are into the present directory. So I just applied a dot here and just go ahead and simply press enter. There's nothing else. So you can see that it says, okay, hey, from using this, so it picked up that as the base image. Now it's running this particular command, which is done, and removing intermediate container. Now it's configuring our container so it's accessible from outside. Once that is done, and it says successfully built. So now if I go ahead and rerun my Docker images, and you will see that now we have another Docker image available into our local repository. So this image we built up using the Wildfly base image. We added some of our own customization or our user data into this image. So now we have an image that contains JBoss with our own custom username, and it's accessible on the so you can accessible it externally pretty much. And if you recall, when we tested the Wildfly image, it was exposing two ports, guys, 9990 for the management and 8080 for your HTTP traffic. So now let's go ahead and we can start a Docker container with the above image just to make sure everything looks good, and we can verify some of the other things. So I'll go ahead and Docker run -d. So -d tells it to start as a daemon instead of interactive. I'm putting a -p, so -p, and I'm saying, let me go ahead and type this command first, and then I can explain you guys. -v, guys. I have written that command, guys. Let me just copy paste that command again. And again, as I said, I'll explain you guys, what I'm just typing here. So let's go ahead and do that. Before I press enter, let me just walk you through the different option. Like as I mentioned, -d, we are telling the Docker to we are starting this command as a basically into a daemon mode, instead of interactive. So if you see that we have specified a -p option twice here. So -p tells the command to assign a local port on our Amazon EC2 instance and forward all network traffic from this local port to these two ports. In this case, 9990 and 8080. So once this is done, you will see that on our Amazon, this EC2 instance, we are going to assign we'll pick two local ports randomly, and we'll bind those two ports to these two ports basically. So that means if we need to forward the traffic to 9990, we will use the random generated port on our Amazon EC2 instance, and I will show you that one again. With the dash v, which is a very interesting option here. So with the dash v command, we are mapping our local directory inside the container. So this will allow the Wi-Fi our case to deploy our Java application, when we drop it into inside this deploy directory. And that's all pretty much. And the last thing that we are supplying Wildfly image is our base image that we'll use to bring up this Docker container here. So let's go ahead and just simply press enter. And as you can see, this pretty long thing, this is the Docker container ID. We can go ahead and verify. Let's run the Docker PS just to see. And as you can see that we have a Docker ID, which is like 43 guys. You can see here the image that we use, the Wildfly admin, the command which is running this, the ports here. Now, if you see that we exposed to port 8080 and 9990, so port 8080 on the Docker container is mapped to 32769 on our local Amazon EC2 instance. So if I need to access 8080, I need to type my instance IP address followed by this particular port. Same thing for 9990, and this is the name of our container. If you don't specify some name, Docker automatically assigns some pretty funny and unique names. So as you can see, our Docker container is running with the above commands. And let me just show you something interesting here too. So if you want to see some more details, we can look at the Docker logs. So do a Docker logs, and then you need to specify the container ID. And as you can see, the Docker container is running fine. Again, the ports are 8080 and 9990, and everything looks good. And the Docker container is fully up and happy and running. Now, like as I mentioned earlier, if you want to test that if we can access the management or the application, we will go to the browser, we'll supply our EC2 instance public IP address followed by these ports. See, let's see if we can do that or not. So if I take this as my public IP address, and if I go to the browser, obviously just waiting, there is not much. But now let's see if we want to go to the JBoss management. So I'll pick this port, and let's go ahead and supply the port, guys. And let's see if we can access. No, so if you see that we cannot connect to our Docker from outside, and if you recall the reason behind that, that we are trying to access a port which is not the security group is not allowing. So if you go to our EC2 instance security group and look at the inbound rules, we haven't any of those ports opened from for the outside access. So go to the edit and just simply go ahead and click in a rule here. So the ports that we need in this case are the 2 ports that we saw. So now let's go back to the custom rule. The port range in this case, our first port that we want to use is 32768. So let's go ahead and guys put 32768, and it needs to be accessible from everywhere. We'll go ahead and add another custom rule for our second port here. So let's go ahead and do that. And from anywhere, I'll go ahead and add another. I'll add an HTTP rule, and let's just simply go ahead and click save. So what we just told that, hey, from outside, we are allowing access to these certain ports. And we know that this port is mapped to our Docker's 9990 port, which is the management for our JBoss application here in this case. And now we can go back to the browser. So let's go back to your browser and let's see what happens. And you can see it automatically now it's trying to launch something, a management or traffic. So give it a few minutes, guys, and we should be able to log in anytime. And if you want to check the HTTP traffic, we can look for the other port. So in this case, 9, and let's have a look. So this is the HTTP traffic. It says Wildfly, welcome to Wildfly, but you got the idea. Now let's go back to the, we can log into the management console, so it's still loading. But hopefully you got a good idea now that we are running this Wildfly in our Docker, and that this Docker container is running on our Amazon EC2 instance. And while the management still loads, let's go back to the, and you can look at the Docker PS. It says it's been up for how many minutes, and these are the different ports that we have exposed pretty much. So you get the idea, how you can connect from outside. It's pretty easy, guys. So now, if we go back to the, okay, we can log in our username, password, admin, that we supplied when we created this image. And here you go. So we have our Wildfly management console where you can manage. You can go ahead and deploy our application. So now we'll go ahead and deploy our application. So to deploy our application, I'll be using one of the sample applications supplied by the Amazon. Thanks to them, I didn't have to write my own application, so I'm using a sample Java application supplied by Amazon for this demo. But you can use your own application if you got any. So now let's go ahead and download this image. So I have my URL pretty quick, guys. And let's go here and download our. And as you can see, I just went ahead and downloaded our sample application. Now let's go back to, before I deploy, I just wanted to show you something, guys. That was the whole reason we opened this another tab. Now do a Docker logs and look for the container ID here. And okay, you can see that was pretty much the last line. There was nothing else. So now let's go ahead and simply deploy our Java application. And if you recall, so let me just go ahead and show you the Docker file that I created. So when we ran this Docker, when we ran this instance, if you recall, this is the deployment directory inside the JBoss Wildfly where you deploy your application. We have mapped this directory to this local directory. So that means I can just simply go ahead and deploy my application in this directory, and the JBoss will know that, and it's going to do an auto deploy, because that's the good thing. The Wildfly uses the auto deploy capability, and we'll go ahead and download this Java application. It's going to go ahead and start deploying that. So what we need to do, we just need to copy our Java application inside our deploy directory. Once that is done, guys, give it a few minutes and you can come back here and look at the logs, and you can see it started to deploy the and that was pretty quick. So okay, our application is deployed now, and we verified that on the looking by the logs also. And let's go back to our first tab. We don't have to do anything much here. That was the only thing. And you can do ls on deploy directory just to see, okay, I have my war file that we copied, and now that was got deployed. And if you want to access your application, go back to the browser, and earlier, if you go ahead and look for this is the default page, and I'm sure you guys are familiar who are developer out there. So we need to supply our application name. In this case, the application name is Java EE demo. Just simply go ahead and press enter, and here you go, guys. That we deployed the sample application provided by Amazon. So this application runs on top inside your Docker, on top of your Docker container, which is running your JBoss. So how you can see it's very easy to pretty much make use of your Docker containers and EC2 instances, and I can, we can simply go ahead and deploy more Docker containers if you guys want, like, and we can go ahead and deploy different applications on one host. So let's go ahead and do that one more time. So we'll just simply go ahead and so let's go ahead and we'll use the dir, or let's we'll go inside my app too, and let's cd my app too, guys. Simply copy, and we're pretty much using the same stuff over here for our demo. We'll keep it same, and we don't have to create a new image, guys. We'll use our existing Docker image. I'm just going to go ahead and run another instance, so it's pretty easy again. So let's go back, and we do have that, but I'll go ahead and download that one more time just to be quick. And now let's go back to our, okay, so we'll go ahead and do, instead of app 1, we'll use app 2, and rest of the things are pretty much same, guys. So let's go ahead and press enter, and you can see that was done. Do a docker ps, and as you can see that we are running another container, but this time if you look at the ports are the local ports are different because these are randomly generated ports. And if we need to connect inside to this Docker container, the application running inside this Docker container, we need to allow these ports on our security group. So let's go ahead and add these two ports also our security group list here. So go back to your, look at the rules. We'll go ahead and add a custom rule again, guys. And pretty much it's from everywhere. And let's go ahead and add one more rule for our another port, and just go ahead and simply click save. Once that is done, now let's go ahead and just simply deploy this inside too. So let's go ahead and verify that that was got deployed. And as you can see, it says it's still deploying. And we can go ahead and look at the logs, and this say this is also deployed. So if I do the docker ps again, guys, this is the port 32771. So let's go back to the browser, and let me see the IP address is 52, 50, 52. And let's go ahead and supply our another port, in this case Wildfly, and give our Java EE demo. And here you go. So now you have multiple containers running on your host, and you got the idea how you can expose your that how can you access these internal Docker ports on your Amazon EC2. You need to go to the security group to allow access to these ports. But that's the whole idea, guys, that it's you can run your applications on the Docker container. So what we just done so far, we just created a Docker image with the wildfly, some of the things. But what we can do in the next thing, in the next lab now, we'll go ahead and bundle this application, this our Java EE demo application, with our container. That way we don't have to deploy this application separately, or after after creating the Docker. So we want to have everything, guys. So hopefully you get the idea here. So I'm going to leave these guys running. So I'll go ahead and create another directory here, and we'll call it my app 3 basically, guys. And let's do a my app 3 here. When we are inside this file, I'm going to go ahead and create a Docker file, and I do have the contents already. And guys, again, I'll walk you through some of the command, but a lot of commands, same whole command. So, okay, now let's go back. Okay, guys, so I created this Docker file. Let me just go ahead and explain you this file pretty quickly again. From you recall that this is our base image that we'll be using to build our own stuff. Pay attention to the add command here. So the add command basically it tells a Docker to build when you are building. So when that command that we run the command Docker build. So at that time we are telling Docker build it to copy a file. In this case, our Java edemo.war from an external location to the image. When we are creating this image, hey, that time go ahead and download this file and include that in the image basically. So this command is executed as the root in the container, guys. Just remember. So when you are running the add command, the dockers execute this as the root in the container. So the file copy will be owned by root and root. But in our case, the JBoss is running as a user JBoss. So that's the reason. If you see the command that after the add command, we are saying user root. So we are making ourselves as the root user. Okay. And after that, we are running a change ownership command onto that particular file. So hopefully you get the idea. And once that is done, we are changing ourselves to the JBoss user. And after that, we are running everything as a JBoss user. Run, we are creating a directory to store some of our logs. I'll show you why into the when we're going to work with the Elastic Beanstalk of this environment. Now, so if you look at the expose command, in the expose command, if you remember that our JBoss, this wildfly image is exposing two ports, 8080 and 9990. We know 9990 is for management. So I'm no more interested with the management for the time being. For this demo, we'll just stick with our 8080, where we are deploying our application or accessing our application. So we are writing a command expose 8080. So this expose basically tells a Docker build again to expose a network port to the container's host. The base image in this case, we knew that it's already exposing 80 and 9990. So this is what let your browser connect to the file management console and some of the other things. Uh, Technically speaking, there was no need for us to expose 8080 because the base image was already exposing the port 8080 and 9990. However, because we will be integrating this with the Beanstalk, okay? The Amazon Elastic Beanstalk requires, basically it's a requirement for the Elastic Beanstalk that we explicitly expose uh, the ports, basically the network port. So it's not going to look at ports exposed and inherited from a base image. So it's not going to look, okay, whether Wildfly is by default exposing these ports or not. So therefore, we have to really write this expose command and expose this port 8080. If we don't do this here, they'll find, but we will not be able to make use of this image when we'll integrate with the Elastic Beanstalk, because Elastic Beanstalk will have no a way of knowing what port to use and what port to send the traffic. So guys, that's the whole reason we are exposing port 8080 again. So hopefully you get the idea here. So our Docker file is ready. Now we can go ahead and build a new image based on these specs. So we'll use this as the base image. And once the base image done, we'll go ahead and download this file and add into our image. And then because it gets downloaded root, so we are changing the root permission and so on, guys. So hopefully you get the idea. And part of this, when we are downloading, if you see that we are doing a mapping to the deployments directory too here. So what it's going to do, if you recall the deployment, we are mapping to the deployments directory. So as we download, it's going to go ahead and deploy this also inside our JBoss environment. So everything looks good. Now let's go ahead and build our this new Docker image based on the AWS. So we'll use the Docker build command. We'll give it a name again. This time we'll call it Java E demo. Let me just call app. Let's do, okay, guys. Sorry, app 3 Java E. I'll just call it app 3, guys, and we'll specify where is our environment. So as you can see, it's using this as the base image. It started to download this file. It will map it to this directory. It'll take a few minutes, and using root, it's running those commands that we gave. And it's changing the ownership on this particular file and JBoss. And guys, if you see this every time, it's creating some container, intermediate container. So if you see there are multiple IDs, so you can just see it's a layer on one top of the another. And it's creating this particular log directory. It's exposing this particular port again. And we should be done anytime soon, pretty much. Okay. Now let's go ahead and verify that we do have our new image. And here you go. Now we do have a new image, which we just created based on these specs. So now this container contains our JBoss server, our application. So that means now we don't have to download our application and deploy. So as soon as you launch a container based on this image, we will have a container, we'll have a Docker container running with our base image, JBoss, as well as our application. So it's pretty easy. So now just to test that, we can go ahead and launch our Docker run. Hopefully you guys remember -d daemon. We are saying the ports again, 8080, and our image name in this case is app3. Just simply go ahead and click enter, guys, and run the Docker PS again to see. Now we do have another image, okay, where we are just exposing port 8080. Our local port is 32772. So now let's go ahead and add this port into our security group list. So go back to your EC2 management, and let's go back to the security group, inbound rule, add a custom TCP port, accessible from everywhere, and just simply click save. Once that is done, what we just need to do, we will just simply go to this port. So let's go back to the browser, guys. 50, I don't know, 52. And let's specify the new containers, our local port. So here we go. And I'm sorry, we need to type the Java E demo. And here you go. So hopefully you got the idea what we did. So now we have a complete base image bundled with everything. So now we don't have to deploy or download our image separately and then go ahead and deploy that image on our JBoss server. It makes your life pretty easy. So it's very easy to scale. You can create multiple Docker containers. So that's all pretty much. So it's very easy. So if you want to create one more Docker container, just go ahead and run this command, guys. I will create one more Docker. Go ahead and create another one more Docker. So you get the idea now. Let's have a look here. Something interesting. I maybe you may have ran out of resources or something. So let's go back and have a quick look here. Yeah, memory allocation, guy. So my host instance basically ran out of my memory. Sorry, I think I didn't provision enough memory. Yeah, pretty much so. But hopefully you get the idea. You can have a powerful underlying host and you can launch multiple instances. Let me do something here quickly. Go to Docker PS again, and I'm going to go ahead and let's Docker RM. Let's go ahead and remove this Docker. Mm, So go ahead and remove this Docker image. Give it a few minutes, guys. I think we instance is slow because we have pretty much used all the amount of memory. So we'll take a while. We can look here. Let me just see what's going on with my instance. So if I go back to the instance, and if we do under monitoring and look the CPU utilization, okay, and okay, let's go back to the command line and just let's see if we can launch another instance. Sorry, another SSH session, not the instance, my bad. So let's go ahead and simply copy. Okay, guys, looks like my instance is not responding. I may have used all the amount of memory. But hopefully you got an idea, what you can do. So in the part 2 of our demo, I will go ahead and integrate this environment with Elastic Beanstalk. Now that we are pretty confident, that the Docker container is configured as we wanted. Now we'll go ahead and deploy that container to a more managed environment, and we'll use Elastic Beanstalk. So AWS Elastic Beanstalk supports the deployment of your web application from Docker containers also. So by using Docker with Elastic Beanstalk, we can have infrastructure that automatically handles the details of capacity provisioning, load balancing, scaling, and some of the other things. So I'll walk you through in the next demo some of the requirement before we can really integrate this with the Elastic Beanstalk, guys. So I'm going to go ahead and end this session here, and I'll see you in the next session pretty soon. Thanks. Bye-bye.